All right, let's continue chapter 6 by looking at 6.3, medians and altitudes of triangles. Now, if you thought you already were confused about circumcenter and incenter, well, there's a lot more things right here for you to get yourself confused with. So make sure you use flashcards or whatever you have to help you remember these terms. The first one right here is a median of a triangle. Now, what is that? It's a segment from the vertex to the midpoint of the opposite side. Okay, so if I were to use this triangle right here to depict that, what they're saying is that if I start from the vertex and I will need to find the middle of the opposite side. Now, how do I do that? In my diagram right here, I'm just going to eyeball it. But in real life, you would need to find the midpoint of that segment, all right, the opposite. Okay, so once again, you would have to find the midpoint of the opposite side to the vertex to find where exactly is the middle, or else you may not find where the middle is. And the middle is important because that becomes our next term, which is the centroid. But before we get to there, let's take a look at this vertex, and let's say that the middle of the opposite side is right there. So go ahead and draw something like that. And let's do it one more time with this side over here. And if all goes well, they are supposed to meet. So median, it's going to be from the vertex to the middle of the opposite side. And so this point right here where all three lines intersect, that is your centroid. Okay, there you go. Let's take a look at the next part. We talk about the altitude of a triangle. Now, the altitude of the triangle oftentimes get confused with the height of the triangle. And that's not always the case. Okay? The altitude of a triangle is a perpendicular segment from the vertex to the opposite side. So let's say right here, I've got my vertex and it's got to be perpendicular to the opposite side. So I just need to draw a line that goes straight down. Okay, let's take a look right here. From this vertex, and if I were to draw a line that is perpendicular, it would probably be right around here. And I would do that. And then for the last part, we have right there, and the perpendicular would be right around here. So let's go ahead and draw that down. And you should always use a ruler. Okay, good practice. And that right there is our orthocenter. Kind of like the bug spray, right? Ortho. So orthocenter is the point of concurrency for three altitudes. Centroid, orthocenter. How is this useful? I guess it depends on what career you go into. But right here, let's take a look at what the centroid is. So remember, what I tried to do right here to know the difference when you look at a diagram and to determine whether they are uh, showing you the centroid or the orthocenter is one, remember, centroid is the vertex to the median, right? So vertex to the middle of the other side. And so I look at this, I know that I'm dealing with centroid, right? Angle A, vertex, segment, bisect. From point B going down to point F, bisect. Point C going to D, bisect. So we've got right here the centroid theorem. Now what they're saying, and if you could look at the diagram, what they're saying right here is this, that if you take a look at your centroid, or okay. If you look, one segment right here is longer than the other segment. BP is bigger than PF. Hopefully you can see that. If not, I maybe worry about your eyes. So how much bigger is it? B to P is 2/3 of the whole entire segment of BF. PF is the remainder. Well, how much would the remainder be? If B to P is 2/3, then P to F needs to be equal to 1/3. Combine it all together, it's 1/2. So what they're showing you right here is this. To find B to P, if I needed to find specifically this segment right here, I would take 2/3 of the whole entire thing, which is BF. If you take 2/3 of segment BF, which is the whole thing, that'll tell you what BP is. Now, in turn, there's a reason why I told you about this 1/3 segment. Because you could figure out what 2/3 of the whole entire piece is and then subtract it from the entire segment. Or why do all that when you could simply figure out that if I take P to F, that right there will be equal to 1/3 of the whole thing, which is BF. So you could use either two equations to find either the big segment, the 2/3 segment, or the 1/3 segment right here. All right. Next up, let's take a look at like AP. Let's do the same thing right there. Okay, so where is AP? AP happens to be right here, and that definitely looks like the 2/3 segment, while E to P is the 1/3. So they say, look, if I want to find AP, then I take 2/3 times AE. There you go. If I want to find PE, that will be 1/3 of AE. Hopefully you get it. If not, let's try one more time with CP. So right here it says C to P. This looks like the 2/3 segment. That's equal to, so P, C to P is equal to 2/3 of the whole thing, which is C to D. So they have to tell you how long that centroid, or the the centroid is. And what we could also find right here is D to P, and that's equal to 1/3 of CD. So either they tell you one of the segments right here in the centroid, either the 1/3 or the 2/3 part. You're going to have to figure that out by visually looking at the problem and then plug it into one of those equations to find the missing segment. Now, you may be asked to find the centroid, and for some reason the book doesn't give you this really cool equation right here. Remember, if I want to find the middle of 2 points, then you would use the midpoint formula, which was x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Well, that helps you find the middle, right? Well, how about this? If I want to find the middle of 3 points, let's do the same exact thing. I will take x1 plus x2 plus x3, and we'll divide that by 3 instead. That'll be your x coordinate. Then let's find y1 plus y2 plus y3 divided by 3, and that will get you the y coordinate of your centroid. I don't know what voice that is. It was supposed to be like a rich butler or something like that, but I think it ended up being, I don't know, kind of Count Dracula-ish. In between impersonations. All right, moving on. Next up, orthocenter. So remember, with the orthocenter, I put in the notes, that's your vertex to the perpendicular of the opposite side, which happens to be your altitude. So it says the orthocenter is the lines containing the altitudes of the triangles are congruent. And this point of concurrency is the orthocenter. So lines containing AF, B to C, B to D, and C to E meet at the orthocenter right there. So how do you get to the orthocenter? Remember, that is from using the perpendicular, the altitude of each angle. If I want to find the orthocenter, unfortunately, there is no equation. What you do is have to find where is the perpendicular of the opposite side. Okay, so how do you do that? You would need to find, step one, find the slope of a side. So I would find the slope of, let's say, for example, A to C right here. And then step two, remember, find the perpendicular slope. And then we would have to find the perpendicular slope and then use that slope. And I would take like the point and then just start counting using the slope to find where does it finally intersect that opposite side. A little complicated. Yes, I know. But it would be pretty easy if you look on this side right here, if it's vertical or horizontal. Because take a look. If I know where that C to B is horizontal, the perpendicular slope would be vertical line. I would just start right there from point A and drop a line straight down. And you'd be able to help. At least one of the sides will be easy, especially if you have a right triangle. All right? Or a perpendicular or horizontal line in the triangle somewhere. Let's drop down. Take a look at number one. So it says point P is the centroid of triangle LMN. So if point P is the centroid, remember, centroid is from the vertex to median, okay? So if I have vertex to median, remember, we talk about what's on the inside, which happens to be one segment being 2/3, another segment being 1/3. Now they give us right here Q to N. So Q to N is equal to 33, which is the whole entire thing. Great. So what could I do with that? Well, if I'm trying to find Pn, all right, Pn right here looks like the 2/3 part. So what I could say right here is Pn is equal to 2/3 of the entire segment. And remember, the entire segment is Q to N, which is 33. Multiply that, solve it out. I could do a little reducing right here. 33 divided by 3 is 11. 11 times 2 is 22. Next up, I need to find Q to P. So Q to P right here ends up equaling, look, that's the 1/3 segment. So how about we take 1/3 of the whole entire thing, which is 33 once again, and that ends up equaling 11. Hey, add these two up, 22 plus 11, there you go, it is 33. Works out nice. All right. You could just take 33, subtract 22 to find the remainder part. But remember, it's important to know these two equations because if they just ask you to find the 1/3 piece and all you know is the equation to find the 2/3 segment, then you won't have to do two steps. But if you know 1/3 of the entire thing is the smaller segment, then you can just go ahead and use that. So let's take a look. Let's say number 3. We'll do the same thing. They have right here Q to N is 39. Okay, so this whole thing is 39. So we want to find P to N. Okay, so P to N, if I look along that line, that is the 2/3 segment. It definitely looks longer. So that is the longer piece. P to N is equal to 2/3 of the whole thing, which we know is 39. All right, that's 13. If we take 39 divided by 3 and then multiply it by 2, and you got yourself 26. So then Q to P, that happens to be the 1/3 segment of the whole thing, right? It's the smaller. So if I take 1/3 of the entire segment, which is 39 once again, that right there ends up equaling to 13. And there you go. You now know Pn and Q to P. Okay, let's take a look next up at number 4. So it says point D is the centroid of triangle ABC, and then find C to D and C to E. All right, so let's use our diagram. We have D to E is 7. Wonderful. Now we have point D is the centroid. Now the centroid right here, we need to figure out, well, where does centroid happen? It's when we have the vertex to the median. Okay, so if we take a look at the other side, we've got ourselves point C as the vertex, and then it's the middle of the opposite side. So meaning it bisects the segment. A to E is congruent to B to E. So it says, let's figure out, well, what is C to D? Okay, well, where is C to D? Well, C to D is right here. Okay. Well, if we're talking about centroid and we're talking about the inside of it, we got the 2/3 segment and the 1/3 segment. D to E right here looks to be the 1/3 segment. So if you don't remember the equation that we had to find the 1/3 segment, you might see yourself to be in trouble right here, because things are made a lot easier if you know that 1/3 segment, and I'll show you why. Because let's see right here, we have D to E is equal to 1/3 of the entire thing, which happens to be CE, which is a part we need to find. Well, let's start plugging things in. D to E is 7. So 7 is equal to 1/3 of CE. How do I get C to E by itself? We need to multiply both sides by 3. And so 21 is equal to CE. Look at that. How easy is that? So the last thing right here is, let's find C to D. Now I found C to E, which is the whole thing. If the whole thing right here happens to be 21, then C to D, I can go ahead and just say it happens to be 14. All right, C to D is equal to 14. If I didn't think about, oh, let me subtract, well, now that I know the whole thing, I could say that C to D is equal to 2/3 of the entire segment, which is 21, and then you can get your answer right there. We got 21 divided by 3 is 7, multiplied by 2, guess what? You get 14 once again. All right. Let's see. I think centroid, finding out the different segments, we've done that enough times. So let's take a look at number 6. Find the coordinates of the centroid of the triangle with the given vertices. Remember I gave you that nifty equation? Use it. Because if not, take a look what they want you to do right here. They want you to graph. And I know you guys don't like graphing, because every time I ask you to do it, you guys don't do it in your homework for a lot of you, right? So luckily right here, you can use your equation. X1 plus X2 plus X3 is divided by 3. Y1 plus Y2 plus Y3 divided by 3. All right, so let's do that. So let's take -2 plus 1 plus 4, X1, X2, X3. Let's simplify this down. We got ourselves -1 plus 4 is 3. 3 over 3 is equal to 1. We have y1 plus y2 plus y3 divided by 3. put all that together right here. We got -1 plus 8 is 7. 7 plus -1 is 6. 6 divided by 3 is 2. So where is the centroid? It is at the ordered pair 1, 2. All right. I don't think we need a whole lot more for that because you can just go ahead and use your equation. Now, the last one is find the orthocenter, whether it's on the inside, on, or outside the triangle. It's on the triangle if it's, remember, a right triangle. It's on the inside if it's acute, and outside if it's obtuse. So we need to figure out where exactly is the orthocenter. Okay, so what can we do right here? Or actually, sorry, take that back. Remember, orthocenter right here is when you take from the vertex to the perpendicular of the opposite side. So what you're going to need to do right here is let's go ahead and plot your points. Like I said, the easiest way is to graph this out. So let's plot point C. We got 1, 2, 3, 1, 2, 3, 4, 5, 6. There's point X. Point Y is at 3, 0. So there's Y. And Z is over here at 11, 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It's going to be a little bit off out there. And I'll do my best to draw straight lines. And how about this? I'm not even going to bother with straight lines with the bottom because it's already straight. So remember, orthocenter. It's going to be from the middle, or sorry, it's going to be from the vertex to the perpendicular of the opposite side. Okay, so if I take a look right here at, let's say, Y, well, it's got to be perpendicular to the opposite side. Okay, well, we got to figure out, well, where is the perpendicular? And so one of the easiest things for us to do is figure out, well, what is the slope of this line? You might need to use the slope formula. But actually in this one, how about this? How about let's look at point X. If I look at point X and I figure out, well, where is the perpendicular to the opposite side? That would be this right here. Let's take a look at point Z. The opposite side of Z is over here. I can go ahead and draw a line. And with these two lines, they intersect right there at our answer, which is 3, 0. I didn't even have to find where it's perpendicular to this line. So if you're lucky, you might be able to get away with that. If not, then you're going to have to do some work. Okay. Once again, let's take a look at number 11. Let's see if we could put this one together. We have one of our points is at 3, 4. We have 11, 4. And then we have at 9, 2. Luckily right here, one of the things I see, oh, actually, let's do it again. It's 9, -2. Not so fast. And there's R. Okay. So over here is pretty easy. We said whenever it happens to be if one of the sides is horizontal or vertical, I just need to pretty much take the vertex and draw a line straight down or up or down. In this instance, there's the point. I'll go ahead and draw a dotted line like so. And this right here is perpendicular. Okay. On this side, because I didn't use the graph paper, I can't figure out the slope. I could if I really wanted to, but how about this? Over here from P to R, I know what that slope is. So the slope of P to R looks like if I go down one to the right one, down one to the right one, that slope is equal to -1. Well, it needs to be the line needs to go through this point right here, okay? The vertex of the opposite side. So remember, at Q, we're at 11,4. So how about if I know that my slope right here, this slope is -1, right? That means the perpendicular slope is going to be the negative reciprocal of it, which is going to be +1, right? The reciprocal of -1 is 1. 1 over 1 is still going to be 1 over 1 when you flip it. And then one is positive, the other is negative. Well, what do? How about this? You start from this point, and then you're going to go ahead and start counting. What do you count? Count the slope. It's going to have to go up one to the right one, up one to the right one, and you keep going. It'll actually go the same way, the opposite direction. And guess what? What I will find, and then you use yourself a ruler right here, you can figure out where two of these vertices intersect. That happens to be right here. That happens to be your answer, which is at 9.2. There you go. Go ahead. Now you know how to find the orthocenter. There's 6.3. If you have any questions, feel free to email me, ask me, and good luck with your homework.